Mahdieh Schimdt from IQST, where she's the scientific director. Cheers.
Stand here so that you see me. Good morning, everyone. It's great to see you again. And my name is Mahdieh Schimdt. I'm the scientific manager of IQST, Center for Integrated Quantum Science and Technology in Germany. And I've been talking to some of you since the conference started about our center. Now this is a more in-depth overview about our center, our activities, the research that we do. And hopefully by the end of my talk, I can convince you to maybe become an IQST member if you're considering moving to Germany. So we are located in the southwest of Germany, in the state of Baden-Württemberg. IQST was established in 2014. It's a consortium between University of Stuttgart, University of Ulm, and the Max Planck Institute for Solid State Research in Stuttgart. We research quantum technologies of the future. So Max Planck Institute is also located very close to the campus of the University of Stuttgart. They're like 1 kilometer away. And Ulm University can be reached from Stuttgart in about an hour by car or public transport. Now the reason why these three locations decided to form a joint center is the multifaceted disciplines and expertise that we have on these three locations that are scientists. As you can see, we have a large range of disciplines from natural sciences all the way to life sciences, engineering, and also medicine even. So our goal is performing translational quantum science from basic research all the way into applications for different fields, for example, medical diagnostics. Now, as most of you know, quantum systems are extremely sensitive to any noise. So all of these three locations have established very special places where we can actually perform experiments avoiding this quantum decoherence that you're familiar with. So for example, at the Max Planck Institute, we have the Precision Laboratory, which is a noise-free environment for spectroscopy and manipulation of individual atoms, molecules, and nanostructures. We essentially research quantum materials at the Max Planck Institute. At the University of Stuttgart, we have established a Center for Applied Quantum Technologies, and this is a place where we bridge quantum sciences with engineering, forming the new discipline of quantum engineering and working on prototype devices. On our Ulm campus, we have the Center for Quantum Biosciences, where we interface quantum science with biomedical and medical sciences. All of these three buildings are among the most unique spaces in the world, with big concrete walls that basically block any acoustics from getting inside, shielded by large metal sheets that form a Faraday cage and also block the electric fields. And the whole room is then on 100 tons of concrete that is floating on highly pressurized air springs. So basically, all of the pipes and walls and everything in these laboratories are designed in a way that exactly nothing can interfere with your experiment. Basically, there could be an earthquake happening outside and you wouldn't even notice if you're inside these rooms. Now, over the course of this conference yesterday and also today a little bit, we heard a very exciting talks about quantum computing. As fantastic as quantum computing is, and also that popular press will continue to focus a lot about quantum computing, quantum sensing is a much less maybe known field that is actually approaching the market very rapidly, and it has potentially even a wider variety of applications. So with quantum sensing, we can sense motion like acceleration, rotation, and gravity, electric and magnetic fields, and it has broad applications for imaging technologies. IQST attempts to establish Germany's most prominent hub for quantum sensing by developing robust quantum systems and integrating them into quantum sensors with enhanced sensitivity that can beat state-of-the-art sensors. And in particular, we're interested in three application areas, namely mobility, space applications, and healthcare. So in a near future, as we all think, the mobility and traffic will be dominated by autonomous vehicles. Quantum sensors such as spin-based gyroscopes and acceleration sensors will be probably the center or central element to this innovation leap, making sure that you have very precise navigation and calibration of the vehicle's course at all times. Observation of the Earth's magnetic field and gravitational field is also very important. It has applications, so it can basically help us make a global model of our planet. And for example, tracking the gravitation field of the Earth, that is only possible with very sensitive quantum sensors that are miniaturized and they're low power consumption. It can give us information about, for example, volcanic activities or earthquakes, or even information that can lead to studies about climate change. And last but not least, we have the application of quantum sensing in healthcare, which is probably the most prominent area that our researchers are active in. First, quantum MRI. So you have heard of MRI. MRI is used for metabolic imaging for disease diagnostics, together with PET scan, with positron emission tomography. They're very popular tools, and they kind of complement each other because MRI scans are very high resolution, but they are not sensitive, and PET scan is exactly the other way. So nowadays doctors do both of these measurements, and they superimpose these images and they try to kind of overlap them and get information. But the problem with this is that for the PET spectroscopy, you have to inject the patient with radioactive materials, so it's very invasive. So quantum MRI is basically, it benefits from the conventional MRI, but we inject the patient with nanodiamonds that are functionalized, and this technique is called hyperpolarized nanodiamond MRI or quantum MRI. And so basically quantum MRI is non-invasive, and also you don't have to do the PET scan at the same time. The other application is quantum gas sensors. So there are different concentrations of gases in human breath that can be biomarkers for certain diseases such as asthma or lung cancer. And our researchers in IQST have developed a glass cell that can sense the lowest concentrations of gases like NO, for example. And we actually call it artificial nose, this technology, and it can help in lung disease diagnostics. And finally, we are developing we are working towards developing human-machine interface, meaning like we are working on wearable devices that can be used on babies or patients with limited mobility, like coma patients and even animals. Now, you're probably wondering how we go about this fantastic research. That's simple, by hiring brilliant PhD students. So we have a grad school, and basically also the interdisciplinary nature of IQST is reflected in our grad school, meaning that we have established an interdisciplinary curriculum that consists of physics, chemistry, engineering, biology, medicine, and we also offer special training workshops and soft skills seminars to kind of help students develop this thinking out of the box mentality and approach problems from a different viewpoint that is not necessarily conventional. We also have a mentoring program to support diversity and exclusivity in the field of quantum science and engineering for those underrepresented genders that not necessarily find this field attractive because it's dominated by a certain gender. And we also have very unique early career grants to promote scientific independence from a very early stage of your research. So thanks to our brilliant and motivated PhD students like Gregory in the audience, you can talk to him. Our PhD network has become one of the most vibrant PhD networks in the region. So we have PhD representatives who are elected on a yearly term, and they help establish new programs for their PhD students, and they're basically the contact points between the PhD network and IQST administration. So they have developed bi-monthly PhD brunch talks where they talk about their research, they offer lab tours, and this rotates between the different institutes because IQST is very big. And this way they get to know about the research of other PIs, the other PhD students, they talk to them, they network, and they learn about internships and the activities that we have in IQST. And there's a brunch also, there's a brunch involved. So, with the help of the PhD students, we have established a number of very exciting programs for our early career researchers, so not only PhD students, but also on the master and bachelor levels for some cases. One of these very exciting programs is the IQST Blue Sky projects, where we promote blue sky research. Basically, this means a project that is not necessarily in the line of your PhD project. And of course, your supervisor has to be open to this idea of you taking Friday afternoons and working on a different topic. But this is where you get kind of innovation and you get inspired to do something new. And we think that this is the way to go at the moment, because we had a success story of graphene that you heard that they were doing, like messing around the lab on Friday afternoons, and actually he was a PhD student when they discovered exfoliated graphene that led to the Nobel Prize in 2010. And yeah, we think this is the way to go. So for this program, we offer funding to the PhD student and early stage scientists, that you get 40,000 euros, and you have 6 months to 1 year to work on your project. So basically, you can use this 40K to buy small equipments, but you can still use the infrastructure of your labs. So basically, you also need the agreement of your supervisor. You can still continue working in your lab, but if you need some extra equipment or material, or if you need to hire an intern, it's also possible. We have worked with the university. PhD students can hire interns to work on this project. Another exciting thing that we have is the exchange program. So we are very actively collaborating. I mean, everybody is collaborating in the scientific community. It's pretty normal. But we have exclusively 3 partners that we are actually establishing joint graduate school. For example, with the Hebrew University of Jerusalem, we are starting a joint graduate school, and we collaborate very closely with the University of British Columbia and the University of Tokyo, where they also mostly work on quantum materials in these 2 places. And the Hebrew University, they are very, this is basically the hub for quantum startups, and we are learning how to kind of build startups, and we have a quantum incubator where we also fund projects, and we help our students or our young researchers start their own businesses. And the Hebrew University is supporting us to build that quantum incubator. We are also present in international fairs, international industry fairs. So you have probably heard of the Hannover Fair. We've been in the previous years always. We have a stand and we show small scientific demonstrations. We will be present also this year. If you happen to be there in Hanover, come stop by and talk to us. We have official industry partners that we work very closely with. We have joint PhD projects between these companies and IQST, Bosch, Zeiss, Bruker, Siemens, and Trumpf. And yes, so industry, so when we talk about translational quantum science to applications, we actually mean it. Also, we are very active in public outreach. We have a yearly quantum science slam, which is the first in Germany and probably the first and only in the world. I haven't heard of it, at least. We have a YouTube channel. You can go to our YouTube channel and look at our quantum science slam. We try to explain quantum science to the general public. And also another aspect that we are very active in is education, because we think that quantum science should be introduced to the curriculum of school. And we teach teachers, school teachers, quantum science, and we teach them how to teach quantum science in schools. That's also another aspect. And of course, attracting top students. And this is one of my favorite things about my job, that I get to go to conferences like this and talk to brilliant students like you. And you can come talk to me. We are here until early afternoon. You can email us or follow us on Twitter and send us your CV. We always have open positions, and there are multiple number of programs that, in addition to your PhD funding, fully funded PhD positions, you can also work on these side projects. So I would like to thank you.
From the audience?
Thanks a lot. You say the center's been running since 2014, is that right?
Yes.
And have the students been coming in since 2014, or is the training program younger than that?
Yes.
And how many, I'm curious as to how many students are, like how big is the student?
So we have so in the past we had limited funding because the center was funded only by the two universities, but slowly as we got more and more advanced, we got funding from the industry, so we're expanding a lot. But we used to have in the past always something like around 30 PhD students, but because of the industry funding that we got, we are expanding, and we have opened all of our programs to the greater community of IQST, which means because we have around 35 PIs, even the students who are not funded directly from IQST can benefit from our programs. So basically the larger IQST community consists of 300 PhD students.
Wow.
So our events are pretty large.
Okay, and you're this amazing interdisciplinarity that you're targeting across chemistry and life sciences as well. Are you seeing a good balance between those things, like in terms of the applicants that are coming? Or are you seeing?
Yes. I mean, we are kind of heavy on the physics side, as you can imagine,
Right.
but we are working on it, and we actually have a university hospital in Ulm, and we try to recruit more medical doctors who will become our PIs, and yeah, that's kind of a challenge because when you hear quantum
for us as well,
physics,
so
yeah,
that's why I was asking.
it's first quantum physics, but we are getting there, definitely.
Thanks.
Thank you.
Do you also look at hybrid quantum classical systems, in particular sort of quantum system engineering principles that will bring classical systems together with quantum? Because it sounds like you've got a very strong multidisciplinary approach.
Yes, we do that basically. Our quantum engineers are always working on those hybrid quantum system protocols, and that's one of the major aspects of our work.
Well, if that's it for questions, could we thank Mahdieh again?